There are enough vulnerabilities already in the community using which the data in memory also can be stolen. Okay, confidential computing comes into this picture at this juncture. It protects data in use. When used in the sense, it's in process time, and typically our software developers talk at runtime. That is, you have developed an application, deployed that application is running, it is in memory, and it is being attempted to get stolen. Somebody is trying to hack it, get the data which is running inside the memory, which is loaded inside the memory. Okay. Now this is the core content of confidential computing in protecting when it is in use. So let us go further. Now in 1970s, ARPANET, I'm assuming most of you all know about it. This is the US Defense Network actually, where the internet concepts TCP/IP and all have come from, and they had a first virus there called creeper virus. Okay, 1970s. Then I'm randomly choosing some. Okay, and in 2015, it is told that 25% of data requiring security is not protected. So if I have, when it's 1/4, it means that when data, there is some amount of data and 1/4 of it is not being secured, was unprotected. Okay, so high risk, right? Okay. And McKinsey says that 16% of executives say their organizations are well prepared to deal with cyber risk. What is this number? It should have been much high, right? But see here, it's very low. Now about a healthcare, IDX is a survey organization says 89% of their healthcare organizations experienced a data breach in the past 2 years. I think this survey is done in 21-22, and it is a big number. Today morning I've been to one of the hospitals, Aster, and came back. A lot of personal data. I gave blood, and I have my data there, and I want it to be confidential between me and my doctor, healthcare provider, but not anyone else. But see the number here, it's risky. Okay. Now I will go on to the right side. In this website, the author has said these are the major data breach. Okay. Now I'll just talk about Aadhaar, right? India's, you know about Aadhaar, which is a biometric database. We would have given our fingerprint, which contains personal data of all the citizens of the country, and it is exposed to a data breach. That's what Washington Post has said. Now let me talk about one more thing. In 2013, okay, TechCrunch says 360 million MySpace accounts were compromised by a Russian hacker, but it was not disclosed till 2016. Okay, and Twitter had an incident in 2018, and Yahoo also had an incident. I remember this, but I don't know the year. I'm forgetting. So now users, by the way, my email account was hacked at that time. Yahoo user accounts were hacked. The passwords were taken, okay, and there are problems like this. Now, why this is happening? Because the data is in use when the application is running and processing the data. Because of various vulnerabilities, system security threats present in the system, either it could be in the code. I write some code, okay, and I left a security vulnerability in my code. Now it is easy for hacker to just get that information, and I don't know about it. I think I'm safe, but it's not the case. So this, just giving these statistics to make you aware that there is a lot of importance in protecting the data, and it is not trivial. Okay, we cannot just take it for granted. Sorry. Okay, so confidential computing is a community from Linux Foundation, which has come up with this proposal on how this can be controlled. So a lot of organizations have come together and have proposed, mainly the hardware vendors like AMD and Intel. Okay. So we'll see what is this. Technically, what is this confidential computing consortium defines as? Okay. This technology protects the data when it is in use. So it means by performing computation in a hardware-based trusted execution environment. It means that the traditional hardware architecture of just CPU and just CPU running processing, CPU is all about processing. What it will process? It will process the data. The CPU processing the data in the memory is not just sufficient with respect to the security. So this consortium has proposed In a hardware-based trusted execution environment, this data in use can be protected. Okay, how they do it? They do by isolation. They call it security enclaves. We'll see some interesting diagrams. Okay, now what it will do? It will prevent unauthorized access or modification of applications and data while in use, thereby increasing the security assurances for organizations that manage sensitive and regulated data. Okay. Now, if you take a healthcare provider, a hospital, they will buy a healthcare application, hospitalization, some software that will be installed and running. And our company which has developed that hospital management application should ensure that the security is present in the system. And this application should be running on a hardware trusted execution environment enabled systems that is provided by Intel, AMD, as I said, and there are, excuse me, there are other software providers like Google, IBM, and many other companies which enable and which will ensure this specifications are met and data is handled in a secure way in runtime. Okay. Okay. Now this is a repetition. The second bullet I'm skipping. We talked about the personal data has to be secured, things like that. What happens here is the data and the code are isolated. When I am saying code, it's an application actually. Okay. You would have installed a lot of software, right? Correct. You would have installed a lot of applications in your machine. Now, when I double click exe file and install, it's an application that gets installed on your machine, which is nothing but code. If I'm not using that application, there is no data associated with it. It is only an application. Whereas once I start using this application, the data will come into picture. Okay. Simple example: Outlook is an email client. Exchange server is sitting in somewhere. I work for Dell. There is an Exchange server sitting in some data center. I am at my home. Okay. Now Outlook is an application I've installed. I have not used so far. There is no data, but I've been using it for the last 1 year. I have a TST file. I have a lot of emails that are stored. Now imagine if I apply this principle, that application which is typically referenced as code and my data are isolated. Okay, there is a care taken, and not anyone can just like that access. Okay, so who will be able to access? Only authorized. There will be privileges given. They will only be authorized. I'll give some examples going forward how that is achieved. Okay, this gives a confidence to the organizations, right? A hospital or an institute, university will think that okay, they'll have confidence that even if there's a lot of sensitive data, business critical information like banks, and they'll be able to run their business safely, smoothly, gracefully, even if they're hosted on the cloud environments. Cloud environments are even paramount. Why I am saying that? We know everything is on cloud nowadays. Nobody is hosting applications in their company. Many are migrating to cloud, and cloud is on internet. And we know there are security breaches possible there. So all this confidential computing ensures that cloud providers follow these principles, use the equipment, hardware as well as software, okay, which is in the context of confidential computing. Somebody had a question. Okay. Now I'm just highlighting the data in use is being protected, and the market could grow to 54 billion in another 4 years as per the Everest. Okay. It is a very important thing. A lot of business numbers are associated here. However, there's a lot of research scope because there are interesting academicians sitting in this room. So please make a note, and I would like to encourage you actually. So I'm talking about attackers, unauthorized, authorized, and all that. Who are those people? Who are the actors? Are they human or they're machines, or what are applications? First of all, we'll see who is the target to be protected. That application which is running and the data that is being processed has to be protected. Okay. And confidential computing ensures through encryption and decryption. And this is a standard just any application accessing the hardware. Now the vulnerabilities, vulnerable actors are the actors who could cause problem could be your cloud service provider. Okay. The administrators, there can be administrator intentionally or unintentionally can cause problems. The hypervisor is an infrastructure layer on which virtual machines will be there, and under hypervisor you can have operating system. I'm just assuming you all know what is a hypervisor. In one line, if somebody is not aware, in one line, a hypervisor is a layer that sits on operating system or along with the operating system, so that there can be multiple virtual machines run on that one physical computer with different OS. On my laptop, if I make it as a hypervisor, on top of it, I can run Ubuntu Linux, I can run Windows, I can run CentOS Linux, like that. And moving back to unauthorized actors, host OS could be also a problem because, for example, the kernel inside this OS has a security vulnerability in OpenSSL or somewhere, we can face the problem. Just doing a time check because, yeah, we have. Okay. Now, what are the important abilities the confidential computing brings in here is the code confidentiality. That is, I'm assuming you all have written some program at some point of time in some language. You write the program, you compile the program. In industries, software industries, we call build because we are building a software. Okay. We compile it, we build it, and we create a package of it. In Windows, it will be .exe. In the Linux, it will have a different form. And in our Android type, it will be .apk. That's how you package. Okay. That is the code I'm talking about. That actual code, which is in machine code, which is converted to machine format, machine readable format. That is the code. Okay. Now that has to be protected. Now there are a lot of sensitive algorithms in that code, for example. People can decompile and get the data. There are mechanisms like that. So that has to be protected. So bottom line, code confidentiality has to be maintained. That is one of the objective ability the confidential computing provides. Next is programmability. It is something like this. Because we are talking about the trusted execution environment, right? So you can program it. Like you can program in the hardware while manufacturing in the factory itself with an arbitrary code. That is one way. Or you can put some limited set of operations and fix that at manufacturing time. You can decide, right? What are the capabilities that this hardware TE can provide. The recoverability. Now the recoverability is usually there are a lot of complaints mechanisms like FIPS and HIPAA and more. Sometimes it happens that your infrastructure is not compliant, but you still have to recover from that. So the recoverability capability also has to be there. Where all this should be present is the providers who implement this confidential computing principles. Okay, I was talking about Intel, Google confidential VMs and things. I'll share those things. Now, authenticated launch. You install an application in your machine, you can just double click and it opens and you start using it. It should not be that simple. Internally, as per confidential computing, there has to be a check before launching it. That is, who is our user trying to run this application? Is that user authenticated properly? Is that user authorized properly? Okay. What happens here is typically, for example, I'm just thinking an example here. You can log into some websites or your organization websites, institutes, companies, whatever. Privileges will be given to you as a user only. Okay. Simple example, if there's a database, okay, some database running in the company, you are supposed to allowed to log in and see what is there in the data, but you cannot modify it. You're a read-only user. But there is an administrator who is a database administrator can modify it. That is the authorization. The role authorization will check, are you allowed to make any change? Okay, so coming back to confidential computing principle, the users who try to run the application will have to be authenticated and authorized before launching. So attestability is very important thing. Probably we can talk in some deep dive sessions in later sessions. All it will ensure is this request or whatever. So two parties are there, two components are there, two users are there and running on an application. One is a client and one is a server. Okay. How will client ensure that am I talking to the right component whom I'm talking to? For example, you have Ravi Gullaplli has developed a website called www.ravigullaplli.com. Okay. Now you try to access that. How will I ensure that, or how will a client ensure that he or she is accessing the right website? The source of truth, the origin of truth has to be attested or authenticated. The attestation word you would have heard. when you apply something, right, for any admissions in schools, colleges, they say I need a gazetted officer attestation on that. What does that really mean? You will approach one gazetted officer, your father's friend or mother's friend or uncle or somebody. They say, then you will take your original certificate saying, uncle, this is my BTech certificate. I'm applying for ISRO or DRDO, whatever. And they're asking for an attestation from a gazetted officer. That person will now see your degree, original degree, and knows, okay, fine, I agree, I understand, I vouch for you, and then attest. The concept is same here. The word is used here as attestability. Okay, so such an evidence is provided here also. The hardware TE environment which is involved will vouch for the manufacturer actually. So I'm a user. I'm a user in the sense I'm in a hospital. I'm an IT manager in a hospital, and I'm using the hospitalization management software, and now which is running on an Intel-based hardware. Okay, that Intel-based hardware will have to be watched. It will have to be signed. So that confirmation will be provided here. Okay, and data confidentiality is only authorized and authenticated will have the access to the data, not everyone, when it is in use, by the way. Okay, even administrators cannot see in confidential computing. And data integrity is confidentiality is viewing the data, read only. Integrity is accessing and modifying the data. Okay. The next one is code integrity. That is, when I have an application installed on my machine, Outlook, for example, if I'm normal user, originally in the past, I can go and wherever it is installed, I can go and delete that. But confidential computing will ensure that that code, that application, the binaries, the libraries are not being just allowed to be removed. Okay. So how much time I have, Dr. Jagan? I'll rush through a little in between.
Please, Ravi.
Yeah, sure. Okay. So team, this is we covered. To achieve confidential computing, the technology what I've been talking about is all about the hardware TE. We'll see a little deep dive we will do. There are other technologies called homomorphic encryption and secure trusted platform modules. Using these parameters that I have discussed just now, what is supported by TE, what is supported by encryption, and what is supported by TPM, we can see in the table. If you see this table and believe this table, we understand clearly the hardware trusted execution environment stands best, because it supports all, but not others. So I'll not focus on this. I just captured the one slide for this, but however, this is the most important. Okay. Now, typically, this is how it looks. This is the core of the confidential computing. Now, you assume this is the hardware. So on top of it, you have an operating system. In that hardware, you have CPU. Okay. What is the CPU will do? CPU will process the application, run the application. Okay. Simplest example, I'm taking Outlook, I'll stick to that. You install the Outlook application. When you open that Outlook client, it will open. That window will open on your machine. You will see, you will send emails, receive emails. Okay. Now, like that in your computer, you will use more applications. Right now, I have a Chrome browser open and more whatnot. I have some coding, Eclipse is open, many things. Now, they are all seen as untrusted applications, but they will be allowed to be accessed with all authenticity and authorized checks. There is a concept called secure enclave or a trusted application enclave, which I'm showing as a green box here, referred from this website. And this is the same form. I mean, I like this figures I've taken. So inside the server, every application will have its own dedicated, isolated part actually. That is called isolated execution environment, like this. And you have one more for another application, one more for another application. Like boundaries are there. So we all stay in apartment, unfortunately nowadays. Some, not all, some of us. Okay, now it is all same building, same roof, same foundation, everything, but we have been separated to some walls in between. Okay, there is security between each flat, something. Now in each of secure, even in that enclave, secure enclave or a trusted application enclave, code and data are also separated. That is the foremost requirement, security requirement for any software development actually. The code is that implementation, that programming language that is compiled and transformed into a binary form is called code, and data is the data, the actual information that the code processes. Okay. So Technically, these enclaves are nothing but private regions inside the memory, and CPU knows how to manage that. So who will be able to do this? The vendors, organized providers who make CPUs. So Intel, AMD, these are the ones very popular. And Intel has security guard extension. They name it as security guard extension. AMD calls it as security encryption virtualization. And Amazon is very popular, calls it as Nitro enclaves. Is there a question or just? Okay, fine. So I'm moving on. Hello?
Sir, you are not audible. You can place the question also here. I mean, post the question in the question. I mean, in the chat window. In that case.
Yeah. Okay. So I'm just continuing. I may skip one or two slides time, but I will talk about this threat model. So I'll just talk about a couple of in 2 minutes. I'll explain what is a threat model. Typically when a software is developed, right? You know the process, software development life cycle. You would have been starting from requirement analysis till testing and releasing the product. And a very important thing is the design phase. During design phase, when we worry about the functionality, scalability, performance, we also worry about security. So when we worry about security, there is an important process step that has been there for last decade or more than that in the software industry, that any application has to be created or represented for its threat model. That is, what are all the possible threat vectors that can come and disturb this application? As a developer, designer, am I ensuring that I am protecting my software application and the users of this application code and data against those threat vectors? Okay, so the attacks can be on the software when it is running, or on the protocol. We use a lot of protocols on the wire, right? Or we have cryptographic. When I'm saying cryptographic, you know the basic thing is a random number. For example, my random number is very small in keys. When I'm generating cryptographic system is all about encryption and keys, decryption, right? How the encryption happens, you generate a random number. That will be your key, and using which you'll apply one algorithm, okay, AES or whatever. Okay, some lot of algorithms, right? You will apply those algorithms. Now, the random number, if I'm a hacker, if I can guess that random number, I can crack your system. Okay. So those possibilities, that kind of an attack is possible. Physical attack is something, if I'm a malicious administrator, I have the access to the lab in the organization, I can spoil it. Supply chain attack is something, you manufacture everything, the company, Intel or Dell, HP or whatever, they manufacture everything, and this goes to the customer. They'll have to ensure it is safely supplied. Okay. Even our Amazon small devices, we buy a lot of things in Amazon. The supply chain also has to be secure. So in supply chain may not be part of confidential computing, but that's an important aspect. So coming back to the confidential computing and the relationship to the threat model here is, we talked about attestation. This system, it has to ensure the attestation, the source of origin has to be validated and verified, and workloads and the data when are being migrated to the trusted execution environments. For normal untrusted systems, if they're going to the trusted systems, okay, the workloads have to support them. The transport should be supported. Data storage, that should be compliant with the confidential computing TE model. When I'm saying TE, is a TE. Okay. Workloads will be migrated actually. So for example, if I'm bank running some traditional application for last 10 years, but I'm seeing all these trends and I'm worried, what if my customer's data is lost? Then I may want to migrate my application and all the data, workload, everything to a trusted execution environment. Now I've been having all my data. I decide to sell everything, all the hardware I will sell, and I will approach one cloud provider like AWS or some other Google or somebody who promise me that I am giving you TE, so I'll go and host all my applications. Okay, so I'll just skip this. Yes, in the interest of time. Okay, here. Now application development support from Intel SDK. So why I'm focusing on this series, when an application is developed, there will be a lot of other activities required along with that. So any application should expose a API. SDK is a software development kit. So if there is a need to interact with the existing system and exploit these capabilities, there is an SDK support from Intel that's called SGX SDK and also Open Enclave. And the cloud providers typically are Microsoft Azure. This provides all software capabilities wrapped on top of this hardware, which actually is a hardware trusted execution environment. And Nitro Enclave is also similar to that. Google Confidential VMs is also similar to that. And IBM also has a concept called Secure Enclave. They have a suite of services called HyperProtect services actually. They give virtual machines, they'll give database, they will give cryptographic capabilities, all in this it will be embraced inside this confidential computing. Okay, so I think this is just a non-secure world and secure world, protected hardware resources. I just talked about this, another pictorial representation here. Okay, utilization paradigms in the sense, how would I say? An application will have to be developed, okay? And the developer should know that evaluate and implement trusted and untrusted components. When we are writing code, right, when implementing code, I use the right English here. When I'm implementing code, I should be, as a developer, should have the distinction in my mind and evaluate this code, what I'm implementing now, is it going to be part of a trusted component or untrusted component? I cannot view them in the same. I should be conscious about that fact. Okay. And as a developer, I also should know that is this program meant to be run on a trusted execution environment, or it is for some as a software development kit for the third-party vendors to use this and write programs. Okay. And I should be able to move portability also. I should think as a developer. That is why I'm saying portability, application running on AMD to Intel or Intel to AMD. Now I don't care, right? Probably my machine is on Intel, and I can take the same PPT and I can go to another machine. Irrespective of the processor, this will run. So that is the portability I'm talking about. And runtime deployment systems, it's more in the industry side where when you are running or installing the applications, right, it should have the cross-TE deployment support. That is, I should be able to support on Intel or AMD or one in a heterogeneous environment. I should be able to convert that application. I should be able to deploy the unmodified application. That is an existing legacy application, and which is running on a plain old Intel some processor. Now I should be able to just deploy it on the hardware TE based, the confidential computing supported hardware trusted execution model. I should be able to deploy that. So these are all the principles that are being considered as utilization paradigms. These are use cases. I will not go to everything. In public cloud, it is applicable. It's applicable in mobile and personal computing, POS devices and payments also. Simple example, if POS is your device where you insert your card, enter PIN, right? What if that keypad is also hacked? That's possible actually. That those things also come under the purview of confidential computing. Okay. And typically the banks type of organizations, right, where there's a lot of data security, they deal with a lot of securities, secrets, keys, tokens, and all that. There are some specific devices. I'll talk about something called hardware security module. This is a special device where your keys are generated for encryption, decryption, and all that in a hardware device. Okay. Unlike I can write a software for encryption, but that is flashed inside a hardware module, which is nothing but a hardware security module. So I'll just talk about this quickly. I'll show you. These are some. If you are interested in confidential computing, ensure you know all these concepts. The public key infrastructure where all your certificates are exploring implement are applicable actually using this technology. You have your GPG and PGP keys, which provide you web of trust. PKA provides a chain of trust. These keys provide a web of trust. This is an independent subject on its own. And I'll talk about bring your own key. Many companies, what happens is many banks, for example, they will say, okay, my application is hosted on your cloud environment like AWS, but you don't give me any security keys. I have my customers' data. I have my own proprietary software which will generate keys, which will encrypt my data, decrypt my data. All I want is your infrastructure, that's all. I'm not interested in using the keys that you generate. I will get the key and bring my own key. It means that bring your own key. So that's it. That's about it. And IBM has a concept called keep your own key. Storing, it's like you keep something, right? You keep your own key, the concept from IBM. I think I just found this. Okay. I just took a sample example from this website. This is something called hardware security module. Traditionally, when this got introduced first time, all these enterprise kind of organizations used to buy this, like they buy server storage networking. They used to buy this device, connect to the computer, and ensure that all the cryptographic operations are taken care of. Simple example, if there is a server which has a database, this is essentially a database server which has all customer bank account records, and the data has to be encrypted and decrypted. The database server will not have a software which will deal with the key. That is, the data has to be encrypted, the data has to be decrypted whenever it has to be done. It is being done through this kind of a hardware security module. So where all this will be applicable is this. Okay, this is similar to your credit card with chip, right? What happens? You put your card in, you enter your PIN, which is like a key. Then only it will process the transaction. Otherwise, it will. This is considered the most robust, secure device for key management, actually, compared to a software. And where are this is applied? Where this is applicable? This I covered, but I'm repeating. In healthcare, because it has a lot of patient data. And what is the personal identification information? Health reports, date of birth, age, and all. Now your financial sector, nothing to say. It's quite obvious. Your bank accounts, the balance, your Aadhaar, PAN, whatnot. In education, it is all about the student records. You have the ID proof, date of birth, again the parents' information, parents' date of birth, parents' ID proof, etc. Okay. Now in government services, we have a lot of government operations, right? BBMP or in Bangalore, or PAN with the income tax of India, and with state governments, you have the property information. You pay the tax, you pay the current bill, electricity bill, water bill, whatnot. So this is all the personal information. Probably it may not be so obvious for the people to think this is so important, so secure. Now things are so public. Now I dial my number in a mobile, somebody dials my number, Truecaller says it is Ravi Gullaplli. Okay, and Ravi Gullaplli, somebody says they will get my mobile number, Gmail account. Then they will go to my Facebook. Okay, unfortunately, that kind of connectivity is there through technology. So in such circumstances, how to ensure that is all protected, that people cannot exploit. Okay. So that is where is the promise from the confidential computing. Some commercial products here which I covered partially while talking: Intel SGX, AMD Security Enclave Virtualization, IBM HyperProtect Services. As I told, they provided the virtual machines. Here the example is I was part of this team, by the way. These three, I was working here for 2 years. What happens is, Ravi Gullaplli is a developer or a freelance consultant and wants a virtual machine, cannot afford to buy another server. I want a powerful virtual machine, computer I want essentially. I can't put money and buy. I want it only for 2 months. I'll go to Amazon, okay, and say, give me a virtual machine. Now I want to put a lot of sensitive information. Now, if assuming AWS gives the services with the context of confidential computing, just they can give the VM to me, that's all. They will not be able to do anything. The complete access to the VM will be with Ravi Gullaplli only can do anything with that. That level of security is what confidential computing will give. And there I have other suite of products here. Microsoft Azure also is an excellent stack, which is providing the confidential VMs and all the attestation services and more. Google also has something similar, which is based on the AMD processor. And there are more actually, like Amazon Nitro, Anjuna, Photonics. There are more players here, which are the public implementation actually, who are all part of the consortium. Okay. This is, I'll just not spend a lot of time. This is another way of achieving confidential computing, but not as powerful as hardware trusted execution environment, which is called as homomorphic encryption. Here what happens is no decryption will be there. When a user, there's a user is accessing a system, trying to search for something, assume the data at rest is already encrypted. User is searching for that. The operation and the processing of the data happens on encrypted data, and the results also will be in the encrypted form. That is the ability of the homomorphic. But there are some flaws, as we saw in the table much earlier in the presentation. And this is about the trusted platform module. It is one more. They have a microcontroller that secures all the artifacts in the platform actually. They also provide attestation and things like that. They have their own technology, so I'm not spending a lot of time on this. Okay. Some references I have. Okay. So this is another interesting table I took from this Anjuno, who are one of the active players of the confidential computing, because they talk about a lot of things. Data protected when disk is stolen. Okay, data protected from unauthorized cloud provider admins with valid credentials. Now, in this kind of risks, if encryption is done at hardware level, will it take care of everything? The answer is no. Software level disk encryption, answer is also no. Likewise, file level client-side encryption, which is most common actually. This is good to certain extent, but not foolproof. But secure enclaves, what we are talking, is the best thing to happen, best thing to suggest. Anjuna, this is a marketing slide, by the way, from Anjuna, but technically I found the risks interesting, so I just picked this up. Okay, so that's all I have. I have to rush a little bit, just keeping the time in mind. Apologies for that. Any questions? Somebody who had a question chat or something?
Yeah, I have a verbal question in case I'm allowed to organize it. Okay, thank you so much for clarifying the computational aspects of confidence. Yeah. So I have a question relating to confidentiality, integrity, and availability triad. And you focused on the first aspect. And also you drill down into APIs and other tools to build your code confidentially. So try to kind of bridge these two. There is one paradigm in the entire IT industry, which is a CIA triad. Kindly enlighten us connecting these two dots. Another one is kindly expand GPG. We know pretty good privacy, but GPG is new to me. Thank you.
GNU PG, GNU actually, it is GPG is GNU privacy card. GNU privacy card. It is a signing key again on top of PGP. It is just like PGP. GNU PG is a GPG is a GNU privacy guard, which is also used like PGP for signing and as a signing actually between two components. What will happen is if I have component A and component B, and component A has to communicate with component B, and GPG will encrypt the data. GPG will encrypt the data using B components publicly. So once the data goes to component B, B will use its private key to decrypt and get the data and process it. It's just like PGP. And what is the previous question, the triad, you talked about the availability, integrity, and what did you say, sir? Confidentiality.
That triad, how does it align with our context? Just syncing the context.
Okay, I had the slides actually. Availability is not a major focus, but it's reasonably important because as part of security, my focus today has been on the integrity. That is only okay, I'll phrase like this. As part of integrity, unauthorized, unauthenticated users will not have access to the data, the protected data. Okay. That is about the integrity, which is write access is not given. Now, the second one is about the confidentiality. That is only users, privileged users with the read-only access to the data are allowed to view the data. It's a read-only. Integrity is on the write, confidentiality is about the read. Okay, that's how I see. Availability will be the next aspect at an application level. Okay, so that will be more on the functional side of the problem. Definitely, availability is one of the elements that will be typically considered in the threat modeling of any application, but after confidentiality and integrity are taken care. So if the system is not available, it doesn't directly impact security, but there is definitely an impact. So that's how I see it.
Thank you. And one more interesting thing for Indians, maybe there are forums like that in abroad too. Data Security Council of India exists, and I think your products are all compliant with their requirements, or are they working with you in the journey?
Repeat, sir. Could you please repeat if you don't mind?
There is in India an organization called Data Security Council of India.
Okay.
I think the products that you mentioned, they are evaluated by them, or are they in touch with these various vendors? I think you have been actively working with them. That's what I hope.
Okay, not in the current organization, but when I was part of IBM, there were some government organizations who used to come up with this compliance expectations. Majorly, any application, when we talk about compliance, it will be US laws most of the time, but there are some from Europe also, like GDPR, where I was talking about personal identification information. Right? Likewise, of course, I agree, but recent experience I didn't have. Only in the past, I was partially involved with some of the representatives from my employer, not directly dealing with those council members.
Thank you very much.
Yeah, so Dr. Jagan, that's all from me. Any further questions?
I think I didn't see any questions, sir. I mean, Suma, somebody by name Suma, they were trying to ask a question or something. I didn't see any posting. If you want, you can try to ask.
Okay, I think
Yeah, please proceed, sir.
Yeah. Thank you very much, Mr. Ravi Gullaplli, for sparing your time for the today's webinar. It was indeed a very informative session. Thank you, sir, for patiently answering the questions. As we come to the end of the webinar, I request Kishore, IEEE EXCOM member, to propose the vote of thanks.
Thank you very much. It is indeed privilege to listen to Ravi Kumar Gullaplli, and it's interesting to know a lot of paradigms and development aspects of confidential computing, and also has taken us through several related references. In almost every slide, he has given details of the source of information. I think organizers generously will share the PDF file to the attendees so that they can use it for their reference work in their research. And looking forward to inviting you all, as my organization is doing a expo in Karnataka Trade Promotion Organization with the theme of cloud and cyber security on 22nd, 23rd, 24th of this July month. And entering is free to all the researchers. I would be there as it's a COO for Paramount Group. I would be happy to receive you and then connect you with various stalls and people who are keeping the exhibition active. Thank you. And so looking forward to more interaction with Ravi and all the professionals of. Always I see the ITS. ITS brings a lot of diverse speakers to the forum, and then allow the researchers to have the to them, and so both in India and abroad. So it is, I think it's a very vibrant chapter, a very society. So I'm very happy being part of this professional body. And thanks once again to everyone. And There's heavy rain in the background in some parts of Bangalore, and despite some of the initial delays, it has been a wonderful evening. Thanks a lot for everyone for cooperation. Thank you, Ravi and Dr. Jagan and team.
Thank you, Kishore sir, for a word of thanks. Also, I request all the participants to mention their name with proper initials and the mail ID, which will be considered for the attendance in the feedback. Jagan sir, I hope feedback link is shared.
Yes, sir. It was shared already.
Okay, yeah. Thank you one and all for your patient listening the webinar. Have a great day. Thank you. You have a great learning ahead. Good night. This is Dr. Sridhar Algi signing off. Your MOC. Thank you one and all.
Thank you, sir. Thank you.